Do you feel the vibes?
We are going to talk about, we're going to talk about remainder and factor theorems. Okay, so take a look at this polynomial right here. All right? Suppose we know that f has a 0 at x equals 3. If we know that x has a 0 at x equals 3, then we know that x minus 3 is a factor. Okay? Furthermore, we know that this has a degree of 3. So so x minus 3 is a factor. So we know that this polynomial f of x is going to be x minus 3 times some other thing, right? And that other thing, q of s, has to be a quadratic, right? Because this is a degree of 3, x minus 3 times a quadratic is going to make it x cubed. So then how do we find that other q of x? Well, we say f of x divided by x over 3. So f of x divided by x over 3 will give us q of x. All right? Okay. How do we do that? Well, either long division or synthetic division, which we learned last year. So let's remind ourselves long division. Okay? So here we have this. It says factor f of x completely given one of its factors. Okay, so we know that, for example, if you divide 24 by one of its factors, give me a factor of 24. 4. You know that you're going to have 6 with no remainder, right? Okay, so now let's divide this. So we're going to get 2x minus 5. And then here we have 6x cubed plus 17x squared minus 104x plus 60. So remember, make sure it's in standard form and all the exponents starting with 3 are present. So we're good to go. Okay, so let's remind ourselves. So it's going to be the first term divided by the first term. That gives me 3x squared. Put it here. Multiply the entire binomial, the divisor, by it. So we get 6x cubed minus 15x squared. Now, remember what I always had you do is change the sign, and then we're going to add. So it's like change the sign, draw the line, combine. Get it? Okay. So this will always go away, and I have 32x squared. Okay, the negative 104 comes down, and the algorithm starts again. 32x squared over 2x gives me 16x. So positive 16x, what do I get when I multiply? Squared minus what? 80x. Okay, so now change the signs and add. This goes away. What do I get? Negative 24x plus the 60 comes down. Okay. Now, negative 24x over 2x is what these days? Negative 12. Negative 24x plus 60. Oh boy, that gives me a 0 when I change the signs, right? So if you don't get a 0, you did something wrong, right? Because the math says it's a factor. Remember, math is bigger than us, so we, the humans, made the mistake. So now, f of x, which was that cubic function, is now equal to 2x minus 5 times the quotient. Okay, but now this is 2x minus 5 times, I can factor this a little bit more, and I get 3x and x. And then what is this? Minus 2 plus 6. Does that look good? Sure. Thanks for the vote of confidence, guys. Yay, thank you. Come on, pat on the back. Yay. Okay.
It works out.
Thank you. Thank you. Yeah.
So you divide by the first term, and then that result is what you multiply by the whole thing?
Correct.
So by having one factor, you can end the base, you can divide stuff and get what's left and then find all the other factors.
If you are told that this is a factor,
There can be no remainder.
there can be no remainder. If it just said divide, then you can get a remainder. Okay, now let's kick it up a notch because it's no longer algebra 2. Okay, so a little birdie told me you have a quiz tomorrow. Okay, know how to solve this problem. Okay, so let's do this. This is a factor. So let's do this. X to the n plus 2. Here we have x to the 3n plus x to the 2n minus 14x to the n minus 24. Okay, let's take a look at the exponents. 3n, 2n, 1n, 0n. We're good. You see that? Okay. Now, algorithm is the same. Remember in math, it doesn't matter what the numbers look like. The process is always the same. So, x to the 3n divided by x to the n. This is x to the 2n. So, x to the 2n. We multiply x to the 3n plus 2x to the 2n. Change the sign, draw the line, and combine. X to the n minus 2x to the 2n. So this is negative x to the 2n. Drop this one down. Oh my God, it is so beautiful. This over this. What do we get? Negative x to the what? X to the n. Okay, let's multiply. Negative x to the 2n minus 2x to the n. Change the signs. And combine. Okay, it's actually draw the line, change the sign, combine. It just seems weird when I do it the other way. Yeah, draw the line, change the sign, combine. Yeah. Okay. Micah, you're having issues with this. What's going on, Micah?
Never mind.
Okay.
I'm having issues too.
Negative 14 plus 2, negative 12x to the n, minus 24. Yay is right. This divided by that, negative 12. See, look, always write these down because you want to see like a visual in front of you, right? So, negative 12x to the n minus 24. Okay, now, f of x is equal to x to the n plus 2 times x to the 2n minus x to the n minus 12. So, f of x is equal to x to the n plus 2. Now, look at this. This is in quadratic form, right? Because look here, we have a constant here. Then we've got x to the 1, then x to the 2, right? So exponent times 2. Here we have constant, exponent, same exponent times 2. So this is quadratic form. When I factor this out, it'll be x to the n, x to the n. Because when you multiply those out, it'll be x to the 2n. So now how do I get these other numbers?
You just do the math.
You've done the
Wow.
That's pretty strong. I have a feeling we're about to get some major juice, but we
I don't thought. What do you do if? Or I kind of forgot.
Hey.
What do you do if the exponents aren't all there again?
You add a 0. You add a 0 x to the 2, let's say.
Okay, got it.
Like this one here, we're gonna. This one
Oh,
is
no,
like that.
Oh, yeah.
Okay.
So I don't think we have to.
Okay.
I think we're going to
Okay. So here, 3x plus 2. Don't write too big on this one. So, look, x to the 5, 4. We're missing the 3, 2, 1, 0. So here's what we're gonna do. 108 x to the 5 minus 36 x to the 4 plus 0x cubed, 75x squared, 36x, 24. Okay, so 108x to the 5 over 3x, what do we get? 36. Yeah, 36x to the 4. So 108x to the 5 minus, what, 72x to the 4? Draw the line. Change the signs.
Less 9. Because it's 3x plus 2. So now it's minus.
What?
Yeah, they're both minus.
Oh, sorry. This was plus, so it becomes minus. Sorry. Okay. So now here we have negative 108 x to the 4 plus 0x cubed. So now negative 108 divided by 3 is negative 36x cubed. So I get negative 108 x to the 4 minus 72x cubed. So let's change the signs. Okay, and what do we get here? 72x cubed plus 75x squared. All right, so 72 divided by 3, 24x squared. So I get 72x cubed plus 48x squared. Let's change the signs. So I'm going to get 75 minus 48, 27x squared plus 36x. Okay, so what, 9x? So 27x squared plus 18x. Change the signs. What do I get? Plus 24. And then what, plus 6? Ooh, 18x plus 12. What's my remainder? Right. So the answer is going to be, all this plus 12 over 3x plus 2. That's it.
This one we don't need to do extra.
No, that's it.
Wait, can you go for 1 second?
3x, just do it.
Okay. Okay, so, okay. Next one. Let's do it super, super quick. These actually are quicker. So here we have x squared minus 5x plus 6, x cubed minus x squared minus 14x plus 4. Okay, what do we put on top first? X.
Don't you... Oh, wait, never mind.
So when I change the signs here, so look, I have to say, even at this age, when I do this, I just take a minute and just change the signs, because sometimes you forget. By the time you're the third one in, right, you lose track of what you were doing, right? Because so 4x squared minus what? 20x plus 4, and then what? Plus 4. So 4x squared minus 20x plus 24 minus plus minus. So what's the remainder? Negative 20. Okay, so my answer is x plus 4 minus 20 over x squared minus 5x plus 6. Okay, now this is fine. Okay, synthetic division, right? Synthetic division is a shortcut. Same thing. You wanna make sure all the numbers are there, all the exponents are there. So like this one, 5, 4, 3, 2, 1, 0. So here I just write the coefficients, and then I take this one, set it equal to 0, 3. Okay, first one comes down for free. Whatever makes it to the bottom row gets multiplied by the number outside. So 6. We add this way, then multiply 6, add 3, multiply, I get 9, add, I get 3, multiply, I get 9, add 4, multiply, I get 12, 4, I'm done. This last number is the remainder. So if x minus 3 was a factor, I would have gotten a 0, but it's not, so I didn't. That's it. Now, these numbers at the bottom give me the coefficients of the quotient. So we had x to the 5th. We divided by a linear function. So x to the 5th, that degree gets reduced by 1. So now I have x to the 4. Right? So my quotient will be 2x to the 4 plus 2x cubed plus 3x squared plus 3x plus 4. This is called the depressed polynomial, not because it's a mental state of being, but because it's physically depressed, right? Like pressed downward. Plus 4 over x minus 3. Isn't that fun? Okay.
So the remainder just always divided by what you divide.
Yeah. Now look at this one. This is different because the divisor has a coefficient other than 1. But you can't have that. So now you have to divide that by 4. Except, look at what you have here. You have that big polynomial to the power of 5 divided by 4x plus 1. So if I divide this by 4, I can't do that. I have to do the same thing to the numerator of the fraction as well. So I also have to divide this by 4. And I don't know if like math teachers don't teach that or something, but like students never remember, so like you have to do that, okay? So now when you do that, what do you have? 12x to the 5, 7x to the 4. What's 68 divided by 4?
17.
Oh, look at you guys. plus 11 over 4x plus, what's 6 over 4? 3 over 2. Later, we'll do it later. Divided by x plus 1 over 4. So check it out. Once you divide, this original no longer exists for us. It's now just about this, okay? Don't go back to that anymore. It's gone. Forget about it. So 12, 7, 17, 0, 11 over 4, 3 over 2, negative a fourth. Okay, so 12, what do we get here? Okay, so 4, negative 1, 16, negative 4, negative 1, ooh, positive 1. Ooh, what is this? Sure. And then what is this? Negative. Okay, anybody want to add that for me? It's 9 over 16. I did it before. I always do my homework before I come. You guys know that. See? And I always, because I want to make sure, like if there are any notes I want to tell you. Okay. Now, what's our answer? 12x to the what?
4.
Plus 4x cubed plus 16x squared minus 4x plus 15 over 4 plus 9 over 16 over x plus 1 over 4. Yeah, but I don't want that. Should I multiply by 4 or 16, you think? 16. 16, because you want to get rid of all the fractions. So, look at this. You have a denominator of 16, you have a denominator of 4. Multiply top and bottom by the common denominator of 16. So, multiply this by 16, multiply this by 16. So, basically it's going to be all this. Do we really need to write it again? No. So, plus, what is this? 9 over 16x plus 4. Cool? Know how to do this. Know how to do this. While we're on this.
Didn't you just multiply the bottom by 16 then? Not really the top, because it just cancels.
You still have to multiply to cancel.
No, but
If you had this divided by x plus 2, how would you do your,
you would add a 0.
I mean, or just don't lose points on the quiz.
Because now you know that you won't lose points because you know that.
You'd be surprised, Evan.
I mean,
You'd be surprised.
I'm the king of mistakes that I shouldn't be making, so.
Huh?
I'm the king of making mistakes that I shouldn't be making, so. In math.
Congratulations.
It's not something bad.
I don't know what the proper comeback for that is. What is the proper response for that?
Just like,
I'm so sorry.
I was trying to boost my credibility. By showing how
Okay. So, remember how, okay, so look, things like this, right? Find f of negative 2. We know how to do this, right? Just plug it in, blah, 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 blah. Okay, so now look. So if something is a 0, right? And let's say x equals 3 is a 0, then x minus 3 is a factor. And if you divide by that, you get 0 remainder, right? Okay, so suppose x equals 3 is a 0, then the value of it is 0. Okay? But if, let's say, at the next point, 4, right? It has some other value. If the remainder here is 0 at 3, then whatever the remainder here is at 4, that's the value of y at 4.
Whoa.
Yeah. Whoa.
That's crazy.
It's cool, right? Because it kind of builds. Okay? So the remainder is the value at that point. And if the remainder is 0, then it's a 0. If yeah, isn't that cool? So if you wanted to find f of -2, you could also do it by synthetic substitution. And this is called synthetic substitution. So let's try that, shall we?
Yeah.
Who's calling? It does make, of course, it makes sense. It's math. Ah, I love math. I do love math. Okay, so 3, -8, 4, 6, -9. -6, -14. I don't know. 28, 32, -64, -58. What's 2 times 58 these days? 107. Okay, it doesn't matter.
But now we know what the y value is.
So now, look. So now we know that f of -2 is 107. Okay, listen. Shh. Stop. The old way was f of -2 is, you don't have to write this down, 3 times -2 to the 4 minus 8 times -2 cubed plus 4 times -2 squared plus 6 times -2 minus 9, 107. And that's fine for a -1 or a -2, but what if it's like a bigger number, right? Now you can do it this way, right? And you can get the same thing. So you can throw away all these numbers, just the remainder itself, it's f of, okay? It's the remainder, okay? Okay.
And then the next one is if it's 0, it's a 0.
Yes! So now, so now, if the remainder is the y value, that means if the remainder is 0, that means it's an x-intercept. It's a 0, right? So it goes full circle. Yeah. Okay. So here we go. I don't think I need to do this, but like, let's just do one of them. Use the factor theorem to determine if the binomial is a factor. So you say, okay, 5, and then here, 1, -2, -13, -10. Yeah, right? Let's just do synthetic division. Oh my God, 0. So yes. Okay? All right, let's just move on.
You can do that to find if it's a factor.
Guys, we just did synthetic. In these 3 problems, we're going to solve the equation, okay? We're going to solve this one, given, not just factor, we're going to solve them, given that x equals -1 is a 0. So we're given one of the zeros. We need to find the other, whatever many, okay? So we know that there are 3, right? Total. So you put -1 over here. Here, okay, 3, 2, 1, 0, all of them are here. So 15, 14, -3, -2. 15, -15, -1, 1, -2, 2, 0. Okay, now let's factor this. Okay, so let's write this down. -1 was a 0. That means x plus 1 is a factor. And then here I get the other polynomial, 15x squared minus x plus 2 equal to 0. Okay? Now.
Wait, isn't it -2?
Sure. Now let's factor this. So it's going to be x plus 1 times. Here I'm going to get 3x and 5x plus 1 minus 2. And then we're done. So x equals negative 1, x equals negative 1/3, x equals 2/5. Now you're probably going to ask me, on the answer space, do I also have to put in negative 1? No, I don't care. Just put negative 1 over 3 and 2/5. If you put negative 1, do I care? I really don't care. I just need to see, okay? Okay. Now, look at this one. Solve this, given that negative 1 over 3 is a root. Same situation. Now it's a root, not a 0, but we know that those two are the same. Okay. Negative 1/3 goes here. Okay. 3, 7, negative 22, negative 8. 3 comes down. I got negative 1, 6. I got negative 2, negative 24, 8, 0. So here I got x plus 1/3. Here I have 3x squared plus 6x minus 24 equals 0. Okay. We would actually move this up. We would actually formally write this as 3x plus 1. Now, from here, I can factor out a 3, right? I'm just going to write it at the front here. So x squared plus 2x minus 8 equal to 0. Let's come up here. 3x plus 1. What is this? X plus 4 minus 2. So x equals negative 1/3, negative 4, 2. Fabulous. Okay? A lot of this we did in Algebra 2. Yeah. Here we go. Find the value of k so that the remainder is 0. Yeah. So same thing. So here, outside, what do I put? Negative 2. So here I have 1, 18, k, 4, 1, negative 2, 16, 8, k plus 8, and then what? Negative 2k minus 16. No. Oh, no, it's, sorry, negative 32. I divided. So k minus 32. And then there are lots of ways to do it, but so this will be 64 minus 2k, right? So for this to be 0, what would this have to equal?
Equals negative 4.
Yeah. Okay, so let's just add them. 68 minus 2k, right? So then 68 minus 2k would have to be 0. So k is 34. And there you have it. That's our lesson. Okay. So
Press start.